Hey, AP Psych students, this is Mrs. Sewell. Today we're going to go over Standard 4 of learning. This is all about biological and cognitive factors and how they affect our learning. In humans, we have instincts, and a lot of times instincts will have a big influence on our behavior, but learning overrules our instincts most of the time, not all the time though. Learning itself is just an evolutionary advance over our instincts. So we learn to do things that we've learned over things that are instinctive to us. But we'll see there are a few cases where instincts overruled learning. Okay, so how does biology play a role in learning? In classical conditioning, Watson and Skinner as well both believe that it was 100% nurture. What you learned was who you were. And so it's all about behaviorism, and behaviorism is all nurture over nature. I like this quote from Watson. It says, "Give me a dozen healthy infants well-formed to my own specified world to bring them up in, and I'll guarantee to take anyone at random and train him to become a type of specialist I might select. Doctor, lawyer, artist, merchant, and even a beggar, man, and thief, regardless of his talents, penchants, tendencies, abilities, vocation, and race of his ancestors." So the idea is they could take a baby and make it anything they wanted to because it's 100% nurture. Now today we know in psychology that it's about 50% nurture and 50% nature. So your genetics and your your predispositions are there, and then you learn in your environment the rest of it. That's the nurture part. Biology will limit what an organism can be classically conditioned to learn. And one of those examples is taste aversion. Once you develop a taste aversion, it's very difficult to overcome it. Right? With operant conditioning, Skinner was exactly the same way. He believed that it's all nurture. And so he said free will is but an illusion. So he believed that everything we are is learned. It's through conditioning. It can be operant or classical. And he didn't believe that our thinking or instincts really drove the bus. It was all about what we had learned. And so he ignored biology and believed that you could overcome it. Now, one example that says Skinner is wrong is the idea of instinctive drift. And that is where animals especially have instinctive drift, where they revert to their natural behavior. A couple named the Brelands, I don't remember their first names, did animal experiments and found that there are certain things that animals cannot be trained to do. One of the things they did was they would teach a raccoon to pick up a coin and put it in like a banker. It's almost like one of those gumball machines. So a machine that would bring out food. So the raccoon would pick up, say, a quarter, put it in the machine, food would come out. So they taught the raccoon that behavior. The problem was when they gave the raccoon 2 quarters, he went back to his natural instincts, and his instincts, when raccoons have 2 of something, they rub them together. So they'd rub the coins back and forth together, and they wouldn't put it in the bank for the food. Same with pigs. They also did an experiment with pigs, and they could teach a pig to pick up a coin, put it in the bank, and get the food. But ultimately, the pigs would revert back to they root. So they push it into the ground. So they would root the coins into the ground. So they couldn't overcome their natural instincts. They could be trained some behaviors, but it wouldn't overrule their natural instincts because of instinctive drift. So you want to know instinctive drift, be familiar if you see Breland, that was their experiment. All right, then you also have a guy named Garcia. He's the one that you'll see. He did it with culling. They did a study on rats and associations. So at the time, they believed that Pavlov's classical conditioning, that through classical conditioning, all the associations that you made would be learned equally. And so remember, in classical conditionings, the unconditioned stimulus has to be immediately after the neutral stimulus, which becomes the conditioned stimulus. So ring the bell, feed the dog, ring the bell, feed the dog. Garcia gave rats flavored water, and while they were drinking it, he exposed them to radiation. Right? Later, a couple hours later, the radiation would make them sick. All right, and they would start vomiting. Next time they wanted the rats to drink the water, the flavored water, they wouldn't drink it. Okay, so they developed a taste aversion. They believed that the water signaled their sickness. All right, and so the finding out of Garcia and Kohler is that biology limited what they could do through classical conditioning, because those rats were not going to drink that flavored water anymore. And so our need for survival, to adapt for survival, over power. So again, this is something that goes against classical and operant conditioning. You've got instincts, and then also biology. It's going to stop us from learning certain things. Okay, same with humans. We develop taste aversion. When it comes to food and it is paired with sickness, all of us have eaten something and then gotten sick on it. Then that conditioning is really strong. It's very hard to break a taste aversion, even if you eat the food and you get sick hours later. It doesn't have to be eat the food, throw up. It could be hours later. I remember when I got food poisoning the first time, I ate shrimp in the afternoon. I also ate chocolate covered cherries later in the day. And then at night I got sick. I can't eat shrimp or chocolate covered cherries anymore. And so even though it was hours afterwards, I have a food aversion for both of that. Now, whatever it is, it has to be salient. The food has to be noticeable. So salient just means noticeable. All right. Then the next kind of issue that comes up that goes against the idea that classical conditioning and operant conditioning are the only ways we learn is the idea of latent learning. A guy named Tolman, and yes, you need to know his name, did a study, and they put rats in a maze and let the rats wander around. They didn't get any kind of reinforcement, so there's no operant conditioning here. They just let the rats wander around the maze. They thought at that time that in order for them to solve the maze, they would have to be given reinforcements. However, later, when they wanted the rats to run the maze and they offered a treat, they found that the rats who'd been allowed to wander around the maze actually could solve it very quickly, much more quickly than the rats that had never been in the maze before. And so that meant that the rats, even though they weren't given treats, were actually learning. And so what was happening is they're creating a cognitive map. If you had AP Human, we did mental maps. That's a cognitive map. Remember, thinking is cognitive. So those maps, those rats created a mental map without any kind of reinforcement. So the cognitive map's just the mental representation of the environment. So like I said, in AP Human, you called it a mental map. It's that map that you have that you know how to get from school to home and home to school. Even if you haven't driven it, you would know how to do it. You have a mental representation and you can make a map from someone. All right. And then the concept was latent learning. Learning occurs even though we don't know, it's not apparent until the learner is given some kind of incentive to demonstrate it. Okay. The big finding with Tolman and the rat study, this latent learning, is that reinforcement is not required for learning to occur. And so that was a big deal. This is a big study. So know that Tolman goes with latent learning, and so does cognitive map. It goes with Coleman. So this is a study you want to know. It comes up fairly often on the AP exam. Okay, now you're going to go to your agenda and do the latent learning activity. This is from Lumen. It's a really good activity. It will go through all of latent learning with you, and you'll know probably more than you need to, but you'll be definitely prepared for the test. All right, the next concept after you've done your latent learning, so I'm sure you paused and did that, right? So next one is learned helplessness. This is a Seligman concept. We've talked about this a little before. Learned helplessness is that sometimes we just become hopeless and we resign to our fate that we can't do anything to avoid bad consequences. So learned helplessness, the hopelessness and passive resignation that an animal or human learns when they're unable to avoid aversive events. So sometimes we feel that no matter what we do, we're going to lose. So we just become helpless and we don't do anything. It happens with animals and with humans. So you want to go in and watch this video. I don't know if the sound will record. Let's see. Yeah, I can't. Oh. This was a really good video, and I just want to show you the dog. Let me see if I can find it. Okay, I'm going to turn the sound off. All right, so this is a really good video. This, when I think Seligman and learned helplessness, this is what I think. I picture this video in my mind, so be sure and watch it. What Seligman did is that they actually placed dogs in an experiment where the dogs were going to get shocked. Some of the dogs in the controls group were not chained. They could leave the floor that shocked them. The other dogs were chained, and so it didn't matter. They couldn't get away, and they kept getting shocked. Now, don't be like, calling PETA or anything. This was not a dramatic shock. It was uncomfortable. The second phase of Seligman's study was this one that you see on the video. Hopefully you see it, so be sure and watch it. But what they would do is they'd take those same dogs, and then they would put them in this room where there was a little fence. On half the floor, there was a shock. On the other half, there was no shocking. The dogs that had previously been able to escape would actually hop the fence and go to the place where it wasn't shocking them. The dogs that had not been able to escape, even though they weren't chained in the second part of the experiment or tethered in any way, they just laid down and they accepted the shock. They didn't even try to hop that little fence. It's, it's a low fence, as you see in the picture. They wouldn't even try. And so that was the idea of learned helplessness. And so sometimes when we meet challenges and we feel we can't get by them, we also develop learned helplessness. We'll talk about this because often learned helplessness contributes to feelings of depression. So we'll come back to learned helplessness when we talk about depression. Okay, the next one is insight learning. Okay, again, we're talking about types of learning that are not classical and not conditioning, other ways that we learn. Okay, learned helplessness, when our instincts override, latent learning. Okay, another one is insight learning. Sometimes we have these flashes of insight when we're dealing with a problem that we've been wrestling with, or we've tried and failed and tried and failed. Oprah calls it the aha moment, okay? And so sometimes we have this moment, this flash of insight where we figure it out. For me, it's usually in the morning when I'm getting ready from work. I'm like, I don't know what to do with this lesson tomorrow. It's not working. What do I do? And then all of a sudden, it's like, oh, I can do this, all right? And I have this flash of insight and I come up with it. So that's a lot of times what people say, if you can't figure it out, just sleep on it. And then hopefully you'll come up with a flash of insight. This is called cognitive learning. And so rather than changing our behavior, it changes our mental processes. All right. And so we come up with a new way to figure it out. This is probably one of my favorite experiments. It's Wolfgang, Kohler, and Sultan. So you want to know Kohler goes with Sultan. He studied chimps, and he thought that they could learn complex behaviors after they've been taught simple behaviors. And so what they did with Sultan is they taught him to get bananas. He's very motivated for food, so that's operant conditioning. And so they would place bananas up high, and Sultan had to learn, there would be boxes around the area, so Sultan would learn to stack the boxes and get the bananas, okay? So he learned that operant conditioning, stack the boxes, got it, okay? The next situation they'd put him in is that there'd be no boxes. They put the bananas up high and there would be a pole. And so he would get the pole or a stick and he would knock the bananas down. Okay, so easy enough. All right, so what they did in the final phase is they put the bananas up really high. Sultan couldn't reach the bananas with a stick, and he couldn't reach them if he stacked the boxes. So he couldn't get to the bananas from either of the behaviors that he'd learned through operant conditioning. So he got frustrated, he ran around his, pen, and then all of a sudden he had a flash of insight. He stacked the boxes, then he got the pole, climbed the boxes, and knocked the bananas down with the pole. So he'd never been taught that, but he was able to put the two behaviors that he'd learned together and solve the problem. And so that is Sultan's situation there, okay? And so this kind of tells you. So that means that animals are not mindlessly using these operantly conditioned behaviors, but there was cognition there. He was able to put those pieces together. There was thinking going on, and then solve the problem. So that's insight learning. So remember, Kohler, Sultan,